Yeah. So, it's exactly 5:30, so let's start with what I think will be a highlight, a very special ending of this academic year's public program, a lecture by Carlo Ratti. We're very honored and pleased that he's with us tonight. He's of course not an unknown person, but he will be further introduced later. But I also can say not only as dean of this faculty, but also as a board member of our beautiful AMS Institute in Amsterdam, that we are very happy to have the connection with you and that you're here tonight. My duty today is only to say a few words of thanks. I want to thank Javier Arpa and his team for organizing again a beautiful year of public events in this Orange Space exhibitions, the BK Talks, and special events and lectures like tonight. I want to thank Ulrich Knaak, my colleague, and Thijs Asselberg sitting there, because I think you have initiated this contact between the faculty and Carlo. And of course, I want to thank the Oosterhof group, represented here today by Erwin ten Brinke, Jaap Wiedenhof, and Rudy Royakker. They are here. They also make it possible to have, as a visiting professor in this period, our special guest, Carlo. Having said that, I give the mic to Ulrich.
Thanks, Dick, and yes, applause, please. As this whole thing started with Jaap discussing how we would be able to get some kind of inspiration, it ended up with a link to the Oosterhof group. Oosterhof group is founded by Jaap Oosterhof, and the ones who did their bachelor here are used to this book, Draagconstructie. He was professor for Draagconstructie. Why is this important for me? In my other life, I'm teaching in a structural design institute and structural engineering faculty. They do mechanics. They do number crunching to do a structural design, which is not what fits to us architects. And this is where Jaap Oosterhof was the right person to transfer this into a graphical structural design, which is super interesting to read. When you see current structural design books, which refer to this Tragwerkslehre, Stuttgart style, Georg knows. This is a graphical way of explaining the flow of forces in buildings. And that's something which, is really very nicely done in this book. Philip Bloch's structural design book refers to that, you know that. Refers to this a lot as well. Why am I referring to this? This is the way of physics made accessible for us architects. I'm an architect by education. And this is where this Jaap Oosterhof linked very nicely to the idea of Jaap Wiedenhof and me when we developed this outline. And Jaap is going to explain a bit about that. It pretty much tries to get this engineering linked to our architectural environment. The Oosterhof group, founded by Jaap Oosterhof, is very kind to spend 5% of their winds into a research environment, Quake, and this research environment actually pays very nicely this program. And Carlo is going to be the first one in this setting, but we're going to have 5 years of this kind of setting. So expect every half year this kind of situation. And by this I stop. Jaap Wiedenhoff, now it's you. And you may applause.
Thank you very much, Ulrich. Then it's my honor to introduce our guest, which is quite difficult because I think you all know him. So I'll try to explain briefly why we asked Carlo to take this first session of the visiting professor chair. We thoroughly believe that engineering, architecture, and nowadays computer science should benefit humans. And when you look at Carlo's work, he's a pioneer of neural networks, artificial intelligence, machine learning, but applying that to the built environment on a humanistic ground without being a humanist, I think, but that's for him to answer. He's an engineer, he's an architect, he's a scientist, he's a curator. He's got so much energy, actually, that I wish he would serve and he would be the Julian Schnabel of architecture. But I think that this energy will come over to you in his lecture. Just one brief remark. A lot of the work he did as a curator was on showing systems, making people experiencing systems, not by explaining them, but literally by being immersed in them. I can totally invite you, I would say, to visit the Venice Biennale. If you come into the space there, together with Thomas Auer, another hero of mine also, he made this beautiful immersive experience. You come in, you experience climate change in a way that you can never explain it to people. Then you come into this curated, non-curated experience where you immersively experience what an overflow of information means and why and how we can use neural networks, modern computer sciences to work together with that information. So I don't think we need to be afraid of machine learning, of artificial intelligence. We need to collaborate with it, and I think that the man that can tell you much more about it than I can has the floor now.
Thank you, Jaap. Should I use this one or this one? All right. Let me just do this. Good afternoon, good evening, everybody. It's a great pleasure to be here. I'm also very proud to be here. I've been here both in Delft and the AMS for a number of years. I'm very, very happy to be visiting professor this semester. So what I decided today, I couldn't decide if I should talk just about the Venice Biennale or about our work. So I decided to make a mix of the different things, and I'll give you a little spoiler about the Biennale at the end, but I'm happy to talk more about it if you want. But I use as a title, I use Intelligence, which is the title of this year's Biennale. I'll show it in a moment. But first of all, sometimes I start a presentation with this slide. If you need to remember 4 numbers about cities, remember 3, 55, 75, and 80. Cities are only 3% of the surface of the planet, but they're 55, more or less 55% of the population, 75% of energy consumption, 80% of CO2 emissions. So if we can do something to make our cities a bit more sustainable, well, that can be a big deal globally. And what can we do today? We do different things, but one interesting thing that's happening is this convergence of digital and physical. Again, a lot of you are. Today there's a big symposium on AI in architecture. A lot of you were talking about this earlier today. But AI is nothing without data. It's like an empty brain. And today the data and the physical and the digital are kind of converging in cities, and they're opening interesting possibilities, but also interesting problems. And I'll get to that in a moment. We're passionate about that. That's something we explore both at MIT, at Senseable City Lab, in Boston, but also with different labs around the world, of course, including Amsterdam AMS, and also in our design office in Turin, New York, and in London. Now, I wanted to start by showing you a few projects that explore this kind of dichotomy between natural and artificial. And I believe that a lot of the issues we are facing today on the planet is because of the tension, because of the rivalry, you could say, between the natural and the artificial world. And somehow, a better alliance between the two is actually what can help us to rethink our built environment. And let's look at them in the two directions, artificial to natural and then natural to artificial. There's an interesting thing that if you take the word the artificial, and by the way, the definition I'm using, if you want a more philosophical definition, is the definition that's given by Herbert Simon in a beautiful book, The Science of the Artificial. And so basically, if you go from the artificial, which is objects, buildings, the places we inhabit, the cities, and then thanks to data and technology, they're becoming and starting to behave a little bit like living organisms. Basically, networks, sensor actuators are breathing kind of a sort of strange life into what we inhabit. And so that's the first thing. So some of our projects look at that. Sometimes for sustainability reasons. This was a refurbishment of the Agnelli Foundation in Italy. Agnelli Foundation is a large Italian foundation behind Ferrari, the economist Philips, now I think biggest shareholder in Philips. And in this building we tried to actually see how the building could start responding like an animal to people, like an animal, I mean like a living thing, in terms of heating, lighting, and cooling. Sometimes invisible, sometimes visible. This part is the historical part, where we work with Olafur Eliasson as an artist. But again, where the building responds and to the presence and the occupancy of people. Something very simple. It's like, what happens on your computer when there's nobody, you stop consuming energy. When there's somebody, you consume energy in the optimized way based on people's things. In this project, we work on an historical building. This is under construction in Italy. We work with an amazing engineer. We sometimes work for kinetic structures called Chuck Oberman, who's a friend and a colleague at Harvard. And what we did here, there was a big problem. The problem is that is the largest cultural center in Italy being built right now. And the initial idea they had was to do something similar to the British Museum in London. As you might know, Foster did a beautiful cover of the British Museum in London. And, but then the Historic Monument Commission was concerned that the condition of the space would totally change. Of course, you can use it all year round, become a beautiful space cover, like this beautiful space here. But at the same time, you don't experience this like in the past. And so here was about creating like a roof that would be like an origami that could be open and closed. It could be both like it was in the 18th century. It could be closed, like the British Museum, like a cover courtyard, and anything in the middle. Here's a little video of this is the bigger project, including the central courtyard. It is in Modena. Actually, the first part of the site will be unveiled in a couple of months. But see, you can actually, when it's open, you experience it like in the 18th century. When it's closed, it's a space you can use all year round. Now, one of the very old project we did was at the World Expo in Zaragoza. We've been working a lot with World Expos. Actually, I will not show it today, but we've done the French pavilion at the Expo in Osaka. They just opened it a couple of months ago. We've been working the Expo in Milan in 2015, in Dubai in 2020. This was the first one was actually in Zaragoza in Spain. And the reason is that there's something interesting when you're doing expos or temporary things. And the fact is that you can take a bit more risk. So you can actually push a bit the boundary. Now, in Zaragoza, Spain, the theme was water. And our idea was, well, what if you could control actually water by the drop and create like an architecture made of water? This was a pavilion to enter the expo. And the idea that this become like, again, like a living water skin. All the water is recycled at the end and reused, but the idea to control it by the drop. So this was an initial video, not very good rendering quality. It was a long time ago. But you see all the walls are made of water, no doors or windows, but when you approach it, it opens up to let you in. When you're inside, also, the walls expand and shrink based on necessity and use. This was the entrance on one side. The other side was Zaha Hadid Pavilion Bridge that you'll see in a moment. The roof is covered in water. That's Zaha's Pavilion next door. And then the idea that there's too much water, you can minimize splashing by lowering the roof. Or at the end of the day, you can close the building and the whole architecture. Hopefully without anybody underneath. Well, we got sensors for that as well. This was, before the opening, I like this picture. There was this guy who was going to the station, missed the train, you see the trolley, because he couldn't figure out what the hell was happening. This was about testing the sensors that opened the thing to let you in, open the water things when you get in. Also, digital pixels and physical pixels made of water together. And I should tell you now what happened one night when actually all of the sensors that control the building stopped working. And the night we were terrified. We didn't know what would happen. But the night was one of the most fun nights ever, where the building would start responding in a crazy way without responding to people anymore. But then people decided to engage with this kind of living building in a different way. Part of the design, part of the thinking. I showed it because it was water, it was very old. This is something we're working on right now. It was announced last week. And this will be the central place of COP30. COP30 is the Conference on Climate. It's going to be in Belém, in the Amazon, in Brazil. Belém is the city next to the Amazon. And what we did here was actually, if you see this, what we want to do here was, can we almost like bend the water surface, the ocean surface, and turn it into a space for discussion. Belém, for COP, needs a number of spaces for discussion. They lack some infrastructure. And so the idea here is this works like, again, like a living thing, like with submarine technology, goes up and down. By doing that, you can be always exactly at the water level. You're kind of looking at the ocean at eye level. And again, it goes up and down based on how many people you have. The water also enters in, and this will be probably the main discussion place for COP30 in Belém. For us, a way to talk about climate and also to use somehow an architecture that starts from, in this case, from the elements from nature, and does the minimum to make it, in this case, a place to inhabit, to use. And we'll stay in Belém forever as a piece of infrastructure there. Also, what we're going to do, we're going to present it first at the Venice Biennale on the 4th of September, in case you'd like to see the Biennale. I'll be there. And there's also something, for us it was interesting. We'll be in Venice, where it's being built, and then we'll go to Belém. And we like the idea that in Venice, over 40 years ago, there was a very famous project presented, floating, called Teatro del Mondo by Aldo Rossi. But the message at the time was a very different message. The message at the time, at the beginning of POMO, postmodernism, was about, well, architecture can still build like a piece of Venice. Architecture can still talk to the past and historical cities. And here we want to make a different message. The message is, can we actually minimize today, and I'll get more about this later when I tell you about the Biennale, today when population is not growing anymore. I don't think we need to build more. I think what we need to do is fix what we have and also what we nature not against. So for us, it was a way to see what is the minimum thing we can do in order to create a plaza, in this case, floating in Belém. There's a roof that's going to be added in Belém. This is a house of 11 windows, for those of you who know Belém, at the center of the city. And this is a place to have conversations and probably a bit higher than this, but the idea is that we'll float basically at the level. I also want to show you, I said I'm mixing together a project from our design office and from the lab. So this is something that what we've been doing in the first 5 years of collaboration with AMS. So not all of you have seen it. And they started by talking at the time to the vice mayor of Amsterdam. And the vice mayor of Amsterdam at the time was very interested in autonomous mobility. We have been working with Singapore, with the lab in Singapore on autonomous mobility. And so the conversation was what could be done in Amsterdam. But as you all know, Amsterdam and Delft, to a certain extent, is an incredible city that in the past used water, not asphalt, as a way to connect people. And so we started thinking, can we work not on self-driving cars, but on self-driving boats? We call them robots. Well, what can you do with a robot? You can use it to move things around, to move people around. You can use them like a platform in order to sense water quality, air quality, like a dynamic platform. But think about this almost like an archigram on water. So think about like small pixels they can connect. And when you need to do a bridge, you self-assemble it. Or when you need to do a floating stage for a concert, you can create it. If there's an emergency, you create like a dynamic responsive architecture, like a living thing that can help the city, activate the city and the connection between the city and the water. Incidentally, I'll show you later a project Norman Foster did at the Biennale this year, which actually thinks in a similar way how Venice can touch the water in a different way. So that was the initial idea. And I'll show you just a little bit of what we did together at AMS with the team here and the team in Boston. So we started looking at small models here with different type of propulsion, like this, so like water jets. As you all know, today is super simple. You can just 3D print something. Maybe 10 years ago, it would take a long time to do a model. Today, you 3D print it in an afternoon. Then you put it in the water, you test it. This was in the canals a few years ago. Testing the small models. It's very controllable, can go one way, the other way, even laterally. I remember that day we told the mayor, well, no worries. Even if the research fails, we'll open a toy company because everybody was having so much fun playing with these on the canals. And then what you need to do in order to teach this thing, to bring intelligence, to turn it like into a self-driving boat, well, the first thing, this is the data I usually have for cars, is the data I can get from TomTom or you name it. But for canals, you need to collect it. So there was a lot of effort to get all the real-time data about everything else. And then, how does an artificial system see the world? Humans, we have two beautiful eyes, and then with the eyes, actually, we get the 3D model of where we need to move. Well, that's how a robot sees the world. It's a LiDAR. Every second, you get 300,000 data points, accuracy of 1 millimeter. And then that's what teaches it how to move in space, or allows it to understand space, and then you can teach it how to move in space. The interesting thing is with this, little by little, you get also more and more data about the city. And for instance, we've been using this in order to look at the stability of people's other problems in the canals, because in the same way as you use it to teach the robot to move, you can also use it in order to better understand the city. The beautiful thing about data is, you can always use it in different ways like this. So we started collecting data, and then this is the MIT swimming pool. So you see here the LiDAR in the MIT swimming pool. And we were teaching the boat to avoid obstacles, the little boat, different type of obstacles, even very complex ones. This is Wei, our postdoc. After this successful experiment, he was promoted professor. And you see it here. Here you see all the data, and then the system little by little learns how to respond. You can do that in different ways. These days you do it mostly with deep learning, but somehow you teach it how to.
It's very small.
And then we had to do the condition in order to connect the boats and have them connect with each other to create a platform. You see it here. Again, the LiDAR at the top.
Mostly DNP are positive.
It's one of the first one. This was the second system we developed. The student called them the kissing boats, as you see here. And then the kissing boats were in the platform. And then this is where we ended up for 5 years. Now,
this is Lucy. Lucy is a rowboat, a fully autonomous, zero-emission boat that operates on urban waterways, and she can change the way cities work. As congestion and emissions continue to rise, while cities continue to grow, the existing infrastructure of many cities struggles to keep up. Rowboats offer a solution by moving road traffic to the water. By bringing passengers from A to B, or as an on-demand boat, taking you anywhere you want. And they can also help the city as a multi-purpose workboat. Take Crystal. She is equipped to collect household waste to free the streets from heavy garbage trucks. Rowboats are fully autonomous, so they navigate without a skipper and can operate 24/7. In order to sail by themselves, rowboats need to perceive their environment and recognize objects such as bridge pillars, floating objects, and of course other vessels. The primary source of information comes from a LiDAR sensor, but rowboats are also equipped with cameras, GPS, and a digital compass. Rowboat's onboard computer combines and processes all of the data and runs the rowboat software so it can successfully complete its mission plan. After 5 years of development, testing and experimentation, we have now successfully enabled autonomy on the full-scale prototypes. Rowboat is ready for the next step. Join us and let's unlock the potential of urban waterways together.
Or finally, another example of how we can use, again, sensors and data, in this case, looking at informality. So this is what the lab in Rio de Janeiro is doing. Rocinha is one of the biggest favelas in the world, the largest in Latin America. And one of the problems there is that it's so complex. It is so difficult even to describe a place. It's probably one of the few places on the planet where Amazon doesn't deliver, cannot deliver, given the complexity of the place. Sorry. And it's also one of the places where you cannot give property titles to people simply because you cannot describe the urban form. And so here we've been using, again, LiDAR, like the one you saw before, in order to first, as a first step, get a better geometrical understanding with the idea that the mayor committed in order to give in the future property titles to people. If people have property titles, they can take care, of the places they own. At the moment, like illegal, and they don't even own the place they inhabit. Here's a little video about Rocinha. But it's what we're working on in the lab in Rio. 100,000 people, like a big city. So these are just some examples. I could show many more, but about how, again, we can take the artificial, the word the artificial, and sensors, actuators, data, intelligence, can help turn them into something that, again, resembles more the world of the natural. Then, of course, architecture has been engaging with nature in a more literary way. So it's the opposite thing. Here we saw from the artificial to the natural, but from the natural to the artificial. And well, the easiest thing is how do you bring nature itself more as a building block of where we live. So which place is this? Yes, Broadacre City. So Frank Lloyd Wright, Broadacre City. That was, the idea was actually, can we blend cities and nature in a better way? Or the same idea of Le Corbusier with La Cité Radieuse and so on. But we know that that actually gave us this. So in the end, it ended up with the destruction of nature. So what we've been trying to do in the office in particular is actually, can we do the opposite? Take nature and not bring the city out in nature. Again, most of the world, we don't need to build more. And I get back to this point with the Biennale. Again, China lost 2 million people last year. Population declined by 2 million people. Japan, 800,000. We know in most of the world, fertility rates are under replacement. So we should prepare not for building more, but then can we, in this case, bring nature more closer to us in our cities? And we've been doing it for a number of years. There's an old project in the center of Milan that's next to the Scala Theatre for the Trussardi Fashion House. Here we work with Patrick Blanc, who developed the vertical wall concept, now very popular. And then here it was like this kind of small green cloud in a kind of urban living room in the center of Milan to meet people, have a coffee, stay there and work. This is a project from a couple of years ago in Singapore. It was just built, and it's the tallest skyscraper. It's a collaboration a project we did with Big. And here the project opens up to create like a plaza. In this case, a plaza overlooking the city. And we wanted this plaza to become a place where people could go. Having lived in Singapore for a long time, usually one of the problems you have is you feel like in a fish tank. But if you go outside, it's usually very, very hot. And so, nature, green is usually one of the best ways we can reduce extreme temperature. And so the idea in the middle is this kind of plaza that becomes, as tens of thousands of plants, becomes like a small tropical forest. This is when it was planted. If you go now, 2 years later, they're much bigger. But basically, as a public space where people can go meet, you meet other people, or you meet nature in the middle of the building. Or this one is a project in Brasilia. Again, we are working on Rocinha from the lab. This is Brasilia, the beautiful project by Lucio Costa and Oscar Niemeyer. But the project also has some of the difficulties of modernism. It's still based on some of the famous principles of the Charte d'Athènes of the 1930s, on the big segregation between different functions. And if you look at this, by the way, you see those beautiful lakes in the lower part of the image, but the city kind of ignores them. So the city is more like it is described at the time by Lucio Costa like an airplane landing in the Cerrado. The Cerrado is the savanna of Brazil. And so here we're doing the first large extension where we decided to follow the same dimensions of the original master plan, but turn the relationship with nature inside out. In the original master plan, it's more like the artificial landing, like the airplane in the middle of the Cerrado, and kind of on the top of nature. And here we're trying to do the opposite, of creating something much more similar to Barcelona. Same proportion. Incidentally, the proportion of the super quadra in Barcelona is exactly the same proportion that Lucio Costa used in Brasilia. The single block by Cerdà in the 19th century in Barcelona, which is 90 to 100 meters, depending how you count it, is 1/3 of the other one. The super quadra in Barcelona, which is 3 blocks, is the same of Brazil. So we work on that in order to turn the relationship with nature inside out, which is also what we did recently, just last year in this project. If you go to Brasilia, my favorite project by Oscar Niemeyer is called Itaparaci. Itaparaci is the Ministry of Foreign Affairs, which is on the monumental axis. I'll show you again. By Niemeyer, it's on this axis. No, you see it? Yeah, yes. On this axis, and here is where you got all the government buildings. And Itaparaci is the Ministry of Foreign Affairs by Niemeyer, probably the best building. And the same building was redone for the Mondadori publishing house in Italy, in Milan, in Segrate. And last year we started working on it. And here was, again, the idea of taking this, which is, for me, a beautiful building, but again, a building that the idea of the 20th century, a very giant spaceship made of concrete landing in the middle of the landscape. And so we are redoing the whole campus. Again, working at the edge between natural and artificial. Can we inhabit the edges, bring nature closer to the building, inhabit the edges, even if you want to fully preserve the building? But also inside, we use exactly what was there. Initially, it was done with USM, the USM system, the Swiss system of furniture. Oscar Niemeyer picked it when he designed the thing. But we dismantled and remounted it in a different way, and actually working with them in order to integrate nature and other elements in the middle of that. So those are it just reopened the inside, and the outside, the campus is under development. So what I want to say is that I think this relationship, I think we can do a lot as architects in trying to find a better alliance between the natural and the artificial world. And a lot of the challenges we're facing on the planet are really because we've been thinking about the artificial, attention and almost the two worlds being at war with each other. Now, I simplified here. I looked, left to right and right to left, but clearly in reality, it's always like a combination of both. And I'll show you a couple of projects. This was 2018, Milan Design Week. Salone del Mobile asked us to do the opening act of Milan Design Week. That is Milan's Royal Palace. To the left, you see the Duomo. And what we decided to do there was to work again on how to bring nature into the city and also work with climate. And our idea was, hey, could we do like a garden with 4 seasons at the same time? So garden is you moving through space, is like you're moving through time. When you're going inside, these were the initial renderings. You go from, the fall to the summer to the winter to the spring. This was the built one, so using just, the idea was both to bring nature in a place where nature has never been, in the center of Milan, but also to use in a sustainable way, get all the energy locally, and change the microclimate. And if you do it right, you can do it also, you know that when you're cooling on one side in your refrigerator, you're producing heat on the other side. So you're basically using the photovoltaics at the top to manage the heating and the cooling, and again, to create a garden where you could go from spring to fall to winter to summer just with a walk from one side to the other. This is the Royal Palace. This was the built structure, and it was with snow. It was a very, very real snow. It was a very hot Milan Design Week, almost 30 degrees on one side. This was a spring. It was a summer. Summer was very sweaty. We even put Milanese mosquitoes inside. Or, another project I want to share with you is, I think as architects, again, we don't need to build, in most of the world, we don't need to build more. But I think we need to fix a lot of what we have already built. And a lot of this is also about infrastructure. So this was a competition that the mayor of Helsinki, the former mayor, launched, called Helsinki Energy Challenge. The idea was very simple. In Helsinki, there's something that's very good, that actually most of the heating in the city, as you might imagine, Helsinki is a northern latitude, so heating is the main source of energy consumption. And most of the heating in the city is district heating. So it's usually good. You're producing power, and with heat that you produce as a byproduct, you use it to heat the city. So usually very good, but there's a but. And then the thing is that actually a lot of the heating in Helsinki, a lot of the power production in Helsinki still happens with coal power plants. And the mayor decided to close the coal power plants. And so the question was, how can you heat the city in a sustainable way? The mayor was quite brave, because usually cities do the opposite of innovation. It's the opposite of innovation because if you look at procurement in cities, the way it works is that they will look at best practices. But a best practice, if you think about it, is look in the future into the past. A best practice means you go to look at what another city did 10 or 20 years before, and that was successful. They designed it, they built it, they saw it was successful, and what do? You redo the same thing. So you're basically perpetuating the past, even if it was successful. But it's not innovation, it's actually copying from the past. So the mayor was quite brave and decided, instead of looking at that, to launch a global competition, similar to what the X Prize does in the United States. Out of the X Prize, for instance, a number of companies exploring space today came out of one X Prize that was about space exploration. So launch this competition, 250 participants, big teams, 10 finalists, and then the winning projects, 3 winning projects including ours. When I say ours, this was done by our office in New York, but today I think everything we do has to be done in a collaborative way, especially if you look at complex, systemic, urban or infrastructure projects. So in this case, we work with Ramble as engineers who cover many dimensions. It was mentioned before by Jaap, Transsolar, Thomas Auer and team, great engineers focusing on climate. Big companies such as Danfoss, Schneider, Lean Heat is a startup from Danfoss, OP Financial, SVP, Schleit Bergman. Jörg Schleit, probably, for me, the number one engineer for lightweight structures from Stuttgart, who did beautiful lightweight structure. The first way to be sustainable if you use less material. And so Jörg Schleit spent his whole life trying to make very, very lightweight things. And Squint Opera will help us to present all of this. I'll show you a little video and then I'll tell you a bit more about the project. We're excited to present to you the Hot Heart, an innovative solution to decarbonize Helsinki. Here is how we'll do it. And so just a couple of, looking a bit more in detail about, what you saw in the video. First thing also in energy, from the energy point of view today, there's good news and bad news. The good news is what you see to the left. What you see to the left is actually, if you look at the cost for producing 1 megawatt hour of power has been going down dramatically. 1 megawatt hour is quite a lot. If you think about your house, your apartment might be 2 kilowatts, which means you run your apartment, everything for 1 hour is 2 kilowatt hour. Now 1 megawatt is 1,000 kilowatts. So it's quite a lot of energy. And around the world, you can produce in a sustainable way with wind or with solar 1 megawatt hour for just a few tens of dollars. It can be 20, 30, 40, 50, you name it. But anyway, it has been going down like that incredibly. And that's good news. But there's also bad news, is what you see to the right. If you go to renewables, sometimes you got too much wind, sometimes no wind. Sometimes you got too much sun or no sun. And that's why actually in Amsterdam as well, sometimes prices become negative. Not prices in your home, but the overall energy prices, you produce so much, they become negative, or you got not enough wind, and then you suffer, which is what you see to the right. Now, you might say, okay, fine, but then that's what batteries are for. And you're right, but there's a problem. I told you 1 megawatt hour, let's say, is 20 euros, 30 euros, 40, depends. But to produce, to store it in a battery, in a traditional battery, will cost you 100,000, 200,000. So let's say 20 to produce, 200,000 to store. And so imagine a difference, to store that amount. And so our idea was very simple. It was something that if you are an engineer, you would say, we are committing a thermodynamic crime. Why a crime? Because usually power is a better form of energy than heat. But in this case, ultimately, you need to turn it into heat. And so the idea was, why don't you turn it into heat at the beginning, and then you store it as heat? When you run all the calculation, then you see that storing 1 megawatt hour as heat doesn't cost 200,000, but something closer to 200. And then all of the economics changes. And then we started looking at floating structure or embedded structures. The idea, you saw it before, is to the left you produce with all the sources, it can be solar, wind, biomass, and so on. Then you got to the right, and the left already exists. The right already exists, is the district heating. And then the only thing you need to do is to fix the thing in the middle. So to have this hot heart, to have this kind of thermal battery to compensate between the two. And then you use AI to combine the two. And as I was saying, you've got additional benefits, including these kind of beautiful places where people can go and enjoy, public places where people can go and enjoy, understand about the infrastructure and enjoy each other's company and nature. I will spare the think about where to put it, all the work on that. You saw this with the kind of 4 biodomes. The idea, again, is to use a tiny fraction of the energy and you can get a beautiful place, again, for people. I think the only way we can make the transition work is if you're all part of it. And so this was a way to involve people in these kind of public spaces. You use very, very little, you keep it under the dome, and then you can, again, you can create something that people in Helsinki or people visiting can enjoy. And so here are some of the things. I will not tell you more, but it's something originally it was mentioned before by Jaap. I think I started my studies by doing structural engineering, and I love tensegrity structures. And I love what, as I said, Jörg Schleich did all his life of making super lightweight structures. And so this is actually based on one of Jörg Schleich's great structure he designed probably 50 years ago in Germany, which is based on something we all know. It's a bicycle wheel, which Buckminster Fuller would call it tensegrity structure, which is very, very efficient because you are using a compression ring and you stabilize it against buckling using all the spokes. So anyway, it's a good way to use very, very little steel and try to do something solid. Now, I will stop here, but I'll tell you, I've got a few slides about the Venice Biennale I want to tell you. But what I wanted to leave you with is, I think what we all can do, and to take this just as experiments, some of them will be more successful than others, but as an experiment of what I think is the most interesting challenge we all face today. It's not about building more. It's not about expanding our cities, especially in Europe, in the US, South America. If you look at that, some countries are already shrinking, other countries will shrink very soon if you just look at fertility rates. But I think it is about blending better the natural artificial and fixing a lot of the issues of the built fabric and built environment we have. I would suggest we take 5 minutes for a couple of questions, and then I'll tell you more about the Biennale that builds on some of these ideas. Thank you. Thank you. Just a couple of thoughts, and then we can have a longer conversation later.
I think people are too intimidated, Carlo. Maybe we start with a short question first. What I like about your approach is that you combine smart with sensible, which essentially means that cities need to become sensitive. If you look at the analysis you did for Brazil, where do you think that our current cities are not sensitive enough? Where should we change our approach, and how can data help us do that? How can data help us do that?
Yeah. No, thank you, Jaap. By the way, about sensible, sensitive, and so on. Our lab, when we started the lab, people were saying, "Why don't you call it Smart City Lab?" And I always hated the word smart city. And the reason is smart city sounds a bit like you're focusing just on technology, on smart technologies. And so I like the idea of sensible, with double meaning, able to sense, but also sensible. And then you're saying sensitive is another dimension to it, but basically is the data is what can help us to make a more sensible city, a city that, again, puts the emphasis not on technology, but on how to respond to people. And about that, I think it's probably two components. One is what you're saying, is how we can use data to see the city, to read dimensions of the city. We could talk a lot about, there's all this beautiful work done in the 50s, 60s, and 70s, people like Kevin Lynch, William White. William White, for the first time, was actually using Super 8 cameras in New York to film life and understand life of the city, with the idea that if you understand life and how the city works, you can design better spaces. He used that to rethink the public space of New York. We are redoing the same. We got a paper that was accepted yesterday in PNAS, Prishtina National Academy of Science, will come out soon, where we use AI to analyze all of William White, all the footage with Super 8. And then we did the same with new cameras. And then basically, again, how we understand the city. So the first point, as you're saying, the sensible city is about how we can get data that describe better the city. And then the second thing is how data as well can become part of the design itself. And then the city becomes made of sentient, to use another, buildings, so they become like this kind of blended boundary between the natural and the artificial. So that's how I would say.
Any questions from the audience at this moment?
Yes. No. And then we can talk more later, but yes, let's take the next.
Well, thanks first for your nice examples. I wonder, do you produce open data so we as academia can build on it?
Yeah, so what we do, I'm totally for open data, since one of the big proponents of open data in the US at the beginning was Obama, and we actually helped that initiative at the very beginning. I helped London later, they launched a big open data initiative. What we do is, as much as possible, we try to make the data accessible. Not always is possible, in the sense that somehow if you're using like data from a cell phone company, then they might tell you, okay, you can analyze it, but you cannot give it to everybody. So we tried as much as possible to open the data. If we talk to city or to mayors, we try to say, well, you should open it up. We got a beautiful story about data that was opened up by Mike Bloomberg in New York as mayor, and that we analyzed and led to actually a lot of changes in New York in terms of mobility. I can tell you more about the project. So we got a beautiful story. Sometimes, we as in academia, there's that much we can do. So what we can do is, whenever possible, we make it open data, but sometimes if you're using data, it happened to us. If you're using data from apps, from some apps, I think the lab at AMS is working with a lot of data apps, TomTom, and so on. And sometimes they say, okay, you can use it, you can do a great paper, you can define knowledge, but we don't want you to share it with others. I don't know if it is the case with TomTom, by the way, but I don't remember. But what I'm saying is sometimes we do what we can, but again, in academia, we need to sometimes to follow the rules, the strings they come attached with the data.
You mentioned William Holloway White, who was very successful with his cameras to learn about the social needs of the people in urban agglomerations. How do you find out about the needs of people?
That's exactly the thing, I think, by taking William White. So for those, maybe I wasn't planning this. I was planning to show you, but let me show you a couple of things on William White, and then we go back to the Venice Biennale. But I need to find it. I didn't open it. So just for people who might be less familiar with William White's work, here it is, I think. I hope. Just a second. Yeah, should be here. So William White. So yes, here there is it. William White did a lot of work in the 70s, 60s and 70s. Did amazing work in New York. He was one of the few people to start quantifying life in the city, how people use public space. By the way, this is an old idea in planning. If you go back to Ildefonso Cerdà, who designed Barcelona in the second half of the 19th century, and if you read his book, The Great Theory of Urbanization, he writes, I hope one day data will help us to understand the city in a new way. He says almost like a science, like a social science. So William White takes that old dream of Cerdà, and at the time, with what he has, goes around New York to really look at life, how people interact with themselves and with the city. And here's William White. You see him here. That he looks at a lot of films, a lot of sidewalks and public spaces, beautiful footage taken in next to New York Public Library in Bryant Park. This is what he was getting at the time. And, taking all this footage and then analyzing. Some of them. He looks at sidewalk. He looks at this, and looking at how we changing shadows. People interact in a different way. So going back to your question, what we've been doing is actually first of all, we manage, through connection with his family, to get hold of all the footage from 50 years ago. Now, the problem, he says, in one of his books, he says the crux, the difficult thing, is the analysis. At the time, if you look at this, at the time, it would take him hours and a massive amount of students to annotate every slide and measure things. All of that we know you can do automatically with AI. So today you can process, at the time you needed, for an hour of footage, you need a lot of time to annotate it. Today with AI you can process all of his footage. So what we did is twofold. We've been working with Ed Glazer, an economist at Harvard, and we're going with a sociologist, Keith Hampton, who's a sociologist that's been in different universities. And we looked at his footage, then we looked at new footage in the same place, and we looked at what changed. And there's amazing things. For instance, one interesting thing, for me, there's a couple of media articles online, but the paper is being processed. There's a preprint of the paper, which is a NBER white paper. But one interesting thing is that, for instance, today we walk in public space 15% faster than 50 years ago. And 50 years ago, if you look at it, what you can do is use AI and look at when people meet in public space, and then you got two people, then meeting a third person, you got triads, two people meeting, how public space starts encounters. And you see a giant change. In 50 years, it looks like because of this. Now, we walk faster. We use this to connect with others, at least by looking at the data, analyzing the data. And in some of that activity of public space, that 50 years ago, you see people there. You see it in the video by White. People just don't know each other, and in public space they start a conversation and become friends, or so, because they didn't have online other alternatives. That thing seems to be dying, which is interesting because actually public space, I think, is one of the most important antidotes to digital polarization. In digital, you can actually avoid all the people who don't agree with you. But in public space is a place where you're forced to confront diversity. And I think that function seems to be changing. 50 years has changed a lot in New York in this. So that's what's coming out in the article we done. But that was great. A little break. I'll show you just a little bit about the Biennale. I don't want to give you a full spoiler, but if you are planning to be in Venice before November, you'll see it. I will also be there I'm there a few times a month. So the theme is a bit related to what, I'll just give you 10 minutes of spoiler on the Biennale. The theme is related, is intelligence, natural, artificial, collective. My initial idea was to call the Biennale Natural Intelligence, because I thought at a time when everybody is so obsessed with AI, and you say, intelligence, everybody shortcut to AI and ChatGPT. I think there's so much more intelligence in nature and in broader, in collective, in what has shaped the built environment. So initially I wanted to call it NI, then we decided to have a more inclusive title. Spelled like this is the Latin root between Italian and English. Usually the Biennale has an Italian and an English title, both languages. I want to have only one, and that's the Latin root, which has this kind of apocryphal gens. And gens means people in Latin, means plurality. So we want to say multiplicity of intelligence. That was the idea. And, the Biennale, this Biennale is very different than the previous ones. And when the Biennale starts, 1895, it is a place where you take all the architecture from the world and you show it in Venice. And then the Venice Biennale is the first one, the oldest one, and becomes a model for many others. Now, at the time, it was a bit like the World's Fair. You had a place where you could go and see what was happening around the world. Biennale was World's Fair meets architecture. But today, that is useless. Why do you want to do that when you can see things in real time on any type of platform? This something like a big, design boom has 4 million followers, but you can look at things on any platform, and you see things. You don't need a place to look at what happens around the world, but you can have a place as an innovation lab, as an experimentation. And that's what we try to do this year. So intelligence, natural, artificial, collective. And what is the starting point? Well, if you think about it, architecture starts when dealing and mediating with climate. This is L'Abbé Lauger. Abbé Lauger writes in the 18th century in France, and his idea is the primitive hut. It's humans. He writes, if you write those beautiful pages in the first chapter, if you read the beautiful pages in the first chapter, he says, our ancestors were in the forest, it rains, it is humid, and what you do, you take nature and you try to bend nature in order to, in that case, get shelter. And for him, that's the beginning of architecture. We can argue about that, we can debate it, but certainly it is a key component of the beginning of architecture. And if you think about that, Venice itself. This, by the way, if you come to Venice, you'll see a beautiful movie. Will be presented also at the Venice Film Festival in September by Yann Arthus Bertrand, the French documentarist. And this is the Venice Lagoon. The Venice Lagoon was not a place for humans, but actually humans, through different type of intelligence, turned it into what we know today, into Venice, into something quite unique on the planet. So that was, again, a way to use architecture to mediate between the environment and comfort that we need. Well, so if architecture responds to climate, when we see this, that we've seen in the past few months, when we see this, that we've seen in the past few years, or this is Sicily, but you name it, in the past few, again, in the recent past, then it means architecture has to engage with climate in a different way. And, data, we're talking about data, this is the most striking data. If you look at this is just on the data that we've been able to measure until the 1970s. The temperature on the planet is more or less constant, and then it goes up like this. It goes up like this, and you know that last year we were above 1.5 degrees, which was the limit set on a longer time frame, but by the Paris Agreement. And what's happening is that some people said, oh, well, that's only El Niño. Well, it turns out now we got La Niña. El Niño and La Niña are two ways to dissipate energy. So El Niño is a bit, overall temperature are higher because you dissipate less with the oceans. La Niña is the opposite, you get a bit cooler. Well, it turns out this year is La Niña and it's still going up. So that is probably the biggest problem we have, regardless. And we have it even more. People are asking me, well, do we still have it when some countries I will not name them, are now disengaging from this and say, well, we have it even more, how do we adapt? Because architecture engaged with this, usually with mitigation. This one example out of many. The great Richard Rogers, 1990s, wrote a book that was about mitigation, cities for a small planet. But if things are like what we are measuring with the numbers, if many countries are stopping to engage with this, and we're seeing it globally, then I think the key challenge is how do we go from mitigation to adaptation. So how can we, mitigation is reducing emissions, still important, but adaptation, how do we design for temperature during the summer that spike? I said before, we got a small lab in Rio de Janeiro, and a few months ago it was 65 degrees Celsius. Well, it was officially 45 plus humidity. The feeling was like 65. Well, none of us would live much longer outside at 65 Celsius. So somehow, how can we rethink the built environment to focus, to address that? And that's what the Biennale is trying to do. It's trying to do it a bit like as a chain reaction, as a lab. So not, if you want to see an exhibition like MoMA, I think it shouldn't be the Biennale, and I think don't go to Venice. But if you want to see more like a lab, then I think that's what we try to do. So what we did is creating like a lab, bringing together different forms of intelligence. For the first time, we have the largest number of participants, up to 10 times more before, 750, and people from different disciplines, architects and engineers, mathematicians and climate scientists, philosophers, people dealing with food, with agriculture, and so on, working together. Adaptation needs all forms of intelligence and disciplines coming together. The other thing we did, it was a bit of an experiment, was to do an open call. The Biennale usually is one person inviting other people, or even not inviting many other people. When I got invited, I went to talk to prior curator. And I remember I had a nice conversation with Rem. I was one of the 5 people Rem had invited at the Biennale in 2014 in his bar. And Rem told me, well, are you planning to invite anybody? I said, well, Rem, usually Biennale, he did a Biennale that was beautiful Biennale, but it was really mostly his work about fundamentals and very few people invited. So we decided this way to do the opposite, do an open call, and it was daunting and amazing. Daunting because we had thousands of emails. I think we sent 5,000 emails to reply to people and give them feedback and so on. But also amazing because we discovered voices we would not have been able to discover otherwise. Then if you're doing different disciplines, then you want diversity also. You want a lot of people just out of university we would not have been able to find otherwise. A lot of people who got Pritzker Prize, many Nobel Prize winners. Again, different inclusion from the point of view of different type of perspectives and generations. In doing that, we tried this year also to try something else. Architects, I think have a very bad idea about authorship. If you look at every project, it's usually the name of the architect and everybody else is a consultant. In academia, in academic papers, it's different. Everybody's acknowledged, all the names are there, and now in many journals, you also say what everybody's contribution is. So we try to do the same. Everybody there this year has been invited in the same way. Not only just the architect or as a team leader and everybody as a consultant, but we try to do this. And then the final thing we try to do is have the Biennale also become part of a broader node, so engaging with other institutions, so COP30, you saw before the project for Belém, C40, Davos Biculture, Soft Power Club. Again, how to create more critical mass. And incidentally, so we have, I'll show it to you in a moment, we have a place very similar to this one, like an auditorium in the middle of the Arsenale that a lot of people are using, sometimes people from Venice, universities, students, people who want to discuss something, big institutions. If any of you is interested in using, do send us an email. There's still slots open until November, again, to continue the conversation about the Biennale. It's a place for public discussion. We use also a lot of data to look at all this process. So that's one of the projects is this kind of meta project, in which this part was done by Albena Janieva, who you probably know, who also did a beautiful book on OMA and the anthropology of OMA, and Michele Bonino from Torino and Politecnico, and Laszlo Barabasi, who's the father of modern network science. Altogether, they use a lot of data to analyze the process. Now, I will show you now the 750 submissions with 750 slides. No, I'm joking. I'll just give you a couple of glimpses, and then I'll stop. As I said, over 750 participants, 280 projects. 500 are interdisciplinary team. 350 are multi-generational. That was very important. 250 are women-led teams, the largest number ever selected. And 375 are transnational. Again, we shouldn't think about teams, more about one country. This idea of nation-states, very 19th century, can we move beyond it? Again, if we need to face adaptation, is a global issue. Can we work together across boundaries as here? Here you see the images, the design of the exhibition I'm very fond of. It was done by Sub in Berlin. You may know about, you might have seen some of Sub's beautiful work in different in concerts, in fashion, and so on. And it's almost like a living animals. So again, we didn't want to do a MoMA exhibition. We want to do something more like a lab. And so if you look at this as this kind of fractal animal, like you see here, the whole thing works based on these, this kind of organization of knowledge, like a super organism, you could say. I'll show you a little video without doing too much of a spoiler. That's the entrance. The Yab Ulrich mentioned before is with Thomas Hauer. The first two, just a moment, the first two things are, we start with two things. One is the climate of tomorrow, a project that actually puts together ETH in Zurich, Politecnico in Zurich. Transsolar is great. I mentioned before, engineers dealing with climate and an artist called Michelangelo Pistoletto, and they tried to recreate the climate of Venice in 100 years. So that's the first one. The second thing about population. Population, again, is very transdisciplinary. It's a team with biologists, physicists. Patricio Urquiola is a great designer. And that looks at the fact that population is about to go down. We know it. We're close to peak population. So who are we designing for? When I hear mayors that tell me we need to expand our cities, my answer is, for whom? So yes, there's small parts of the planet, small parts of Africa and small pockets in Asia that are still growing, but most of the planet is about to reach peak population. So those are the two things, the parameters of tomorrow are that, and from there you go into natural, artificial, and collective intelligence. In the final section is called Out, with one thing which is written very clearly there, is not because we want to go and live outside of the planet. By going outside can help us to better understand our only home, which is Earth, where we live. So that's written very clearly, and that is also written by a beautiful essay by Lord Rees, Martin Rees, the astronomer royal, who's invited to the Biennale, who really says this is not the opposite of what Elon Musk would say. It is about, this is about going to space to better understand our planet, to use data from satellite to better preserve our only home. I'll show you briefly the video I started before. So the beginning is what we were saying. Here you see the climate. The second thing is this is the hill. And then you start with nature. It's a very raw nature. It's the beginning of the natural. And then really raw nature uses Kengo Kuma and the University of Tokyo using nature in its complexity without having to make it straight, a piece of timber. And then nature becomes more and more tame. So the natural part of learning from the geometry of nature. And then going into materials. There's a section curated by Politecnico di Milano, the person who does set design in La Scala and the Nobel Prize winner who won for graphene, Konstantin Novoselokov. And here you see the different materials. And this is the material part. In the moment you enter into the artificial is where you look at robotics, humanoids. Humanoids are game changers according to many. Here you see different type of buildings. Then you go to the collective. The collective is also at the center. You got this big platform. And then we also turn, this is Foster, before was, again, Diller and Scofidio with others. And this is how the whole place becomes like a lab, how to engage with water, how to engage with some of the issues in Venice. Venice, the most fragile city on the planet, how it can become a lab, not only to save itself, but to develop ideas for others. And this is a part with also different new ways to inhabit. That's a beautiful, this is anyway, we use even the bookshop as an opportunity to design something. This is the Carlo Scarpa. We refurbish it together with Electa and turn it into an installation. And this is a way to turn a part of the garden into a place for working that would be expanded in Italy and so on. So turning the whole space, not only the pavilion, but also the giardini and also all of Venice a bit into a lab to develop ideas. Some will be more successful than others, but I'll have to give you a tour when you're coming to Venice. So here's my little spoiler. Thank you.
Thank you. So I think the floor is open to questions. One of the things you say is something that really interests me. If we start blurring the boundaries, aren't we supposed to think completely different about the bubble we want to live in? Either it's a thermal bubble or a social bubble.
Yeah.
It's at the same time, we seem to be using data to protect ourselves, to create distance, not to create connections. What cultural change do we need to start using these possibilities to reconnect?
Yeah, and I think you're right. In this, I'll go back, and everything, including data. First of all, there's no AI without data. AI without data is an empty brain. So data is the input, but data can be used for good or for bad, like any other technology. What you were saying is, when I was saying before about public space, as I was saying, the conversation tonight, people being able to talk, to agree, to disagree, to have different opinions, is really one of the best antidotes. As I was saying a moment ago, public space is a place of inevitability. On the digital one, you can immediately remove every voice that you don't want to hear, and then you end up in a bubble. That's what's happening more and more. And then public space is so vital. And that's why I think as architects we've got a responsibility. And the work before we were showing about William White that shows that public space might be losing some of that ability because we spend too much time on data is I think, is a key problem. So basically somehow architecture can be an antidote because, again, when we are together, that inevitability forces us to mediate and to understand each other and then to not simply to be in our bubble and then to avoid everybody else. So I think architecture could be part of the solution.
But it does change. It does need a lot of change to the way we approach it.
Yeah. It also the other thing is that I think it has to produce changes in the way we teach architecture. I've seen giant changes in the past. We're discussing some of it today about programming coming into architecture. Now, in most places, somebody graduating in architecture is also a programmer. But I think it has to be much more transdisciplinary. So it also changes also how we teach architecture, and I think also architectural criticism that needs to engage in being able to engage in more complexity. So those are some of the things that need to happen as well.
Yeah, but I think that our 20th century sort of domination of the visual is something then we do need to get rid of. What we discussed before is we design on plants, not on humans. Humans aren't birds. They don't look from the sky. They're on the ground. Yeah. We make renders, which often don't contain and nowadays AI can do that. So for me the question is, and what do you think you can contribute to architects, engineers, project developers, authorities, changing their perspective of what they require from the built environment?
Now, if I had to pick one thing that combines all the things we've been saying probably, and we can look at that, it is about what we need to do is very simple. We just need to learn from nature. And what nature does, for instance, the key thing that we don't do as architects, what nature does, tries things, right? Evolution tries things and see what works, what doesn't work. But the important thing is feedback loops. As architects, we've always been terrified of feedback loops, simply because we don't want anybody to go and measure. We claim that we've done the most sustainable, more social building and so on. And then somebody goes to measure it and realizes it's totally the opposite. It happens a lot. But so that you don't do that. We don't do that. And that lack of feedback is what doesn't allow us. We just need to learn from nature. So the feedback, the interdisciplinarity, the trial and error, the lab approach is what nature does. We just need to copy that. And one of the things in the Biennale you will find, if you look at vernacular, there's a beautiful book by a guy called Bernard Rudolsky. It's a book, I think, 72, if I'm not wrong. It was an exhibition in MoMA, the Museum of Modern Art. And Rudolsky starts by saying most of the architecture we love most on the planet was not done by architects. This is kind of vernacular architecture, what he calls architecture without architects. Now, there's a couple of projects in the Biennale that actually link and refer to Rudolsky. There's a beautiful one done by John Lim and Hong Kong University, for instance. But the key thing there People that look at what has changed. And yes, technology has changed vis-a-vis the vernacular time, when, we were building the Santorini, to a certain extent, it's also the Delft, the Italian villages, and so all these places we still admire from all over the world. Technology has changed. But to me, the key thing is this thing is much more rooted in nature. It's about trying, it's about learning from mistakes, it's about being able, to copy and take the good things and take them forward. Not thinking about everything as a single, is a single building with ownership, and then we don't check how it really works, and we let it there, and we don't take that lesson forward. So I think it's about, in the end, if you want one thing that then deals with how we bring it into architecture, into teaching architecture, into architecture, it is about how can we be much closer to nature as it was in architecture without architects.
So who in the audience is willing to test their own assumptions and their own projects?
And disagree. I think disagreement is great. Yes.
Take it, sir.
Microphone is coming.
Thank you very much. I recently spoke to someone who tried to found a platform for architects where we can share detailed drawings. So we post our detailed drawings and we, in return, get the ones from the other architects. It didn't work because no one was interested in sharing their details. LLMs are mostly based on data, which we just spoke about, and architecture has no GitHub which can teach it how to design. First of all, would you agree with that assumption that we have a huge lack of data in architecture? And do you think that is an opportunity or a threat to architecture in the future?
Thank you. That's a lot of interesting points. Now, let's look first of all, because you're talking about that, and that project is sharing detail. A lot of people are trying that in order to train an LLM. As you know, today you can do text to image. I think everybody, when doing a project, right, you get to do a project at university or in the office, and you need to do whatever, make it up, a house in the mountain next to a waterfall and with a beautiful forest and so on, and large windows, you describe it, and then you get all the images you want of inspiration. That one is what the LLM does is what you would have done until 2 years ago is you go on Google that, and you will find Falling Water by Frank Lloyd Wright, you'll find a bunch of other references, and then you get the thing. Now, what LLM do, they almost do a Google of Google. They look at, not 5 images, but 5 million or 5 billion images, and it synthesizes in the way you want. And so that is already happening. If we add the data to train it, tomorrow it would take just a click to go not from text to image as we do today, right? And I think all of you, I've seen a lot of them in here. I think all of you, when you got an assignment or a project to do, you go do that, and every office does it. But you would do then text to BIM. So you describe the thing and you get your construction thing. So that data is going to come, I think. Still, I think that's not, and so that is threatening because it means all what we are learning to do. At that point, you got all the details that architects have done for a long time. You got, and instead of, as today, you do text description and you get an image. Tomorrow you do text and you get construction drawings. Then if you got some humanoids, you can go text to building, right? You do the thing and then you get your stuff built. Now, that is what several people are talking about. I think still all of this is leaving one important thing that all these systems cannot do. And those systems are hopeless when they need to do what hasn't been done. In the 20th century, there was a great architecture critic, Italian, called Bruno Zevi. And Bruno Zevi writes in one of his books, I quoted him recently, he writes, the people who create a new language architecture are very few. And then you got a large amount of people who can speak it correctly, and then you got an even larger amount of people who can barely, be able to put together some of the species of that language. But, he says, the key thing is about how to create a new language or a new idea or new thing. So if you look at this, if you add, today, if you describe a house next to a waterfall and ask an LLM, most of the times we'll have a good chunk in that out of the millions of images of Frank Lloyd Wright falling water. But, but we'll never be able to do it if Frank Lloyd Wright hadn't done it. We'll never be able to do it before. I'll give another example. Our communications team, when I need to answer questions, usually prepares a draft, and now they train something they call Carlo GPT, which has all the previous books and stuff written. And the thing basically usually is very good. It just basically does a blend usually. But when there's a question that I never dealt with, it totally hallucinates. So it doesn't know how to do it. So what I'm saying is that this thing about it is going to happen, I think. Many people think it's going to happen, that we're going to automate a lot of this. But there's something that will never be automated. And it's the most beautiful and human thing, which is doing what hasn't been done yet. And I think that's what we should focus on, all of us. But I don't know if this thing will happen, what you're talking about will happen in 5 years, 10 or 15, but I think it will happen. A lot of these things have surprised us in terms of speed. And yes, we'll automate a lot, but I think what hasn't been done, then those things are clueless. They will hallucinate. So they're just, a beautiful way to do a Google of Google. In the past, perfect. The future, not. And that's for us to invent.
Okay.
Two hands.
10 more minutes, so we've got a bit of time for a few questions.
Thank you. Just a short follow-up on this consideration. I could not agree more that this is the current state of art, so no creativity in AI models. Will creativity, in your view, ever be included? New algorithms, new ways of dealing with the processes, will that ever be part of the picture? And if yes, is that a plus? Is that a minus? What is your view? Is that a danger?
Okay, no, that's, okay, guys, here we're getting into the territory of basically singularity and all this. So, many of you might know Lewis Mumford. Lewis Mumford wrote beautiful books about cities. One of the most beautiful ones is The City in History. Few people know that Lewis Mumford in the 1930s wrote another book called Techniques and Civilization. And people at the time were also obsessed about the same question. Are machines going to replace us? Now, it is right. It's a fair question what you're asking, because I'm saying with today's systems, they're looking at the past. You train them with a lot of stuff. You train them with all what humanity has ever written, all the books. And these things can regurgitate a paragraph that makes sense. You train, and especially if you tell them what you want, they statistically are able to create something that makes sense. Will we ever be able to have a system? So, and what I'm saying is that what so far they are totally unable to do is actually do what hasn't been done. And that's for us. And it's the most beautiful and human things we can do, to imagine what is not there, what hasn't been done yet. Your question is, will they ever be able to do it? I don't know. I think that there's still so much more intelligence. To me, this system seems so primitive. We were saying today with the students in the classroom, if you look outside, take a tree. I mean, take a tree. A tree is a small piece of code, which is in the seed. And then is able from that to create this incredible architecture of the tree, get all local materials, all the energy locally, creates a beautiful structure, a beautiful design, incredible design, and then when that's over, everything goes back to allow other designs to be created. So my impression is that maybe one day, yes, but these systems are still so primitive versus the intelligence I see in nature or the intelligence I see in humans, in connections, and so on. So they're so primitive. Again, what they are is just a zillion Google with a huge energy cost, because they're also totally inefficient from an energy point of view. And then, yes, they can be very effective, don't get me wrong, but they're not. In terms of intelligence, I still see so much more intelligence in natural and human systems. So maybe one day, yes, but I don't see it coming very soon. Going back to what I was saying before about Lewis Mumford. Lewis Mumford, people were dealing with the same problems 100 years ago, 1930s. And his point at the time was that somehow all these systems and techniques have always been a way to get rid of the things we like less. We don't like that much, and focus on other things we like more. So if we focus for now on what we are unique at doing, which is doing what hasn't been done, I think that's probably not bad. If robots do repetitive tasks instead of having a human who's on a on an iPhone production line that does this all life and then until retirement. I think, so far, I think that could lead to a better world. It still leaves open the question. When that happens, when you're saying happens, then the question is that singularity, and then what happens to all of us? But I still see so much more intelligence in the natural systems.
One last question.
Yes. Yes.
Sorry.
Hi. I have a question about the limits, let's say.
About?
The limits.
Yeah.
Because you talked about natural and artificial, and then artificial to natural. And we talked also about vernacular architecture, and so recovering and learning from natural as the best lab that we can have. But then when we go back into the architecture, I see an architecture that now is going overwhelmed by sensors. So I am asking, which is the limit of this relationship between natural and artificial? Because at the end, if we bring the nature in the city, as you did, but then it's super controlled nature, it's like an artificial nature. So I wonder which is the limit between these two.
Yeah. Well, I would say that it is really, if you look at it more as coevolution, because once you have, sensors, our eyes are sensors. So if you got the LiDAR for the boat, it's like our eyes for ourselves to navigate. If you look at some of the autonomous systems are like weird animals, right? So I think it's more about looking at that not as a limit, but as a kind of a coevolution. And as I said, the reassuring thing is that I still see so much more intelligence from the natural side that I don't see technology taking over anytime soon. Technology has some advantage. The key advantage I think technology has is the following. There's a tragedy in life. And the tragedy in life is that every generation has to do the same mistakes before learning something. You can read all the books, but until when you bump into a wall, you name it which wall. By driving, you bump into a wall, or with a love or a relationship or something, until when you've done it, you haven't learned. Now, the thing where intelligence is much faster is that if you got 5 million self-driving cars, one makes a mistake and all of them learn. So that's one interesting thing about technology. But apart from that, I think I still believe much more in organic and biological intelligence. What I see is really more like this evolution, and I don't think that one will take over very soon.
I think that's perfect closing words. Very comforting to understand that the person who knows probably most about artificial intelligence in this room is very convinced that it's more artificial than intelligence, if I try to summarize it.
It's a nice way to say that, is artificial intelligence.
Thank you very much, Carlo.
But thanks all. I hope that we can continue the conversation, maybe in Venice, if you come before the 23rd. 23rd, by the way, we gave the Golden Lion to Donna Haraway. That was also a point to make exactly some of the points some of you made. That Donna Haraway really looked at how we should go. Anyway, how we should go into new directions, primarily looking at kin and nature. So if you'd like to come, Donna Haraway will come at the end on the 23rd. But if you're there before, let me know, and I hope we can continue the conversation. But thanks all, and thank you for making this possible. And what happens? I had never seen a lecture that starts with drinks. So first we drink and then we talk. So what happens after we talk? Do we have additional drinks or?
I think that's the idea. And I was promising someone with inevitable energy. I think you just proved it. So you need to go surfing. Thank you.